Right, so this is the second half of the WJEC Intermediate Maths Paper 1 from May 2018, and this is the second 40 marks. So circle the best approximate value for the following calculation. Well, they've given us some space, so let's do our approximate to see which one is best. So we're going to round to 300 over 40 plus 10, which is 6, did I say 300? 600 I meant, over 50, which is the same as 5 into 60, which is 12. The number is increased by 4% of its value. This is done 7 times, each time increasing the previous value by 4%. Circle the multiplier that we'd use to find the value after the 7 increases. This is curious because this would normally be, it's a compound percentage question that would normally come up on probably a numeracy, but certainly paper 2 you would expect to see this. So if it's increased by 4%, that means you are multiplying by 1.04. The 4% is the 0.04, and if you're repeating that 7 times, you would be doing that to the power of 7. So 4% increase over 7 years is that multiplier. Calculate 4/5 divided by a quarter. The way that you would likely to have been taught to do this is to change the division to a multiply and multiply by its reciprocal, which means turning it over. So if you're dividing by a quarter, you are multiplying by that. You then multiply the top numbers, 16, and 5 times 1 is 5. Let's have a look. 16 over 5 isn't there, so let's turn it into a mixed number. 5 goes into 16 3 times, with the remainder 1 left over. So it's testing your fraction ability, and the one that we're looking for is that one. Venn diagram, question 11. 30 rugby supporters travel to Cardiff on a coach. They decide to investigate how many of them can sing one or both of the songs Hen Lad Ben Hadai and Bread of Heaven. 12 say they can sing both, 18 say they can sing Bread of Heaven, and 5 say they can't sing either. Complete the Venn diagram below to show this information. The universal set E contains all of the 30 supporters, so everybody has to be represented within that rectangle. So straight away I can put the 5 outside those 2 circles because there are 5 that can't sing either. That means that inside that circle, overlapping circles, there will be 25 people. 30 in total, less the 5 is 25. So that represents 25. But we have to put 30 people into it, because we've got 12 and 18 comes to 30. So the difference between the 25 and the 30 represent the overlap. So 5 are in there and in there. Once we've worked out what that is, we can then work out how many only could sing. Oh, sorry, wait a minute. 12 say they can sing both songs. Sorry, I've misread that. If 12 can sing both songs, 12 are in the overlap. 18 say they can sing Bread of Heaven. So if there are 18 that can sing Bread of Heaven, 12 of those can sing both. That means there are 6 that can only sing Bread of Heaven. So 18 in total. And then we then have to work out, well, what's left? How many can only sing Hen Lad Ben Hadai? We know that all the numbers have to add up to 30. and at the moment there I've got 5, 11, 23. So that means that there must be 7 only that can sing, or sorry, 7 that can only sing Hen Rhad Van Hadau. So if I add those together now, I should get 30. 5 and 7 is 12, 24, 30. One of these supporters is chosen at random. What's the probability that this person can sing Hen Rhad Van Hadau? Well, it's going to be out of 30, because there are 30 supporters, and can sing Hen Rhad Van Hadau is the whole circle representing Hen Rhad Van Hadau, which is 7 and 12. So 19 out of 30 is what we're looking for there. Bit of algebra. Expand and simplify the following expression. So we need to multiply everything that's outside this bracket with each term that's inside it. So we're going to do x times 5x, which is 5x squared. And we're going to do x times negative 2, which is minus 2x. Then we come to this bracket, and again we have to multiply what's outside by each term that's in. So first of all, I've got 3x squared, but it's minus 3x squared. Then I have to multiply those. 3 times 2x is 6x, minus times a minus, the signs are the same, the answer is positive. And then I have to multiply that third term as well. 3 7s are 21, negative, positive, signs are different, answer is negative. So that's clearing out the brackets. Then I have to gather together my like terms. So I've got 5x squared, there's no sign in front of it, which means it's positive, and I've got take 3x squared. Now we've finished multiplying at this point, so it's just moving from plus 5 on the number line down 3 places to end up at 2x squared. Then for my x terms, I've got take 2x, add 6x. Again, I'm not multiplying now, I'm moving from negative 2 on my number line up 6 places. I end up at plus 4x, and then I've got this take 21 that I can't simplify any further because there are no number only terms. So that's it for that one. Part B. Solve 22 take f all over 3 equals 6. So the first thing that we have to do is multiply by 3 to get rid of that fraction. If I multiply that by 3, I have to multiply that side by 3 as well, which leaves me 22 take f on that side and 18 on that side. Now there's different ways to go from here. What I would suggest is, if the unknown is negative, we try to do something about that. If I add f to that side, I have to add f to that side as well. What that then does is leave me 22 on this side, 18 plus f on that side. So I'm going to have a positive value. Now to get the f on its own, I have to take 18 off that. If I take 18 off that, I have to take 18 off this side as well, which leaves me f on its own and 4. So f is 4. It doesn't matter if you work out 4 equals f or f equals 4, it means the same thing. Okay, so from there, back into probability. A fair 6-sided dice is thrown twice. What's the probability that 3 is thrown on both occasions? So the way we write probability is probability 3, and then what we're saying is and probability 3. So the first time it's thrown and the second time. And when you were taught this, you should have learnt that if we're using the English word and in probability, it means we're going to be multiplying the probabilities together. So what's the probability of you throwing a 3 on a dice? 1 in 6. And the second time, 1 in 6. Multiply the top, 1 times 1 is 1. Multiply the bottom. So the chances of you throwing a 3 on both occasions is 1 out of 36. Part B. A company has offices in Llanelli, Carnarvon, Newtown and Ebbw Vale. Its national committee is made up of workers from these 4 offices. Pie chart below shows what fraction of the committee members come from each office. There are an equal number of members from Newtown and Ebbw Vale, so that slice and that slice are the same size. A member is chosen at random from this committee to be its chairperson. The probability that the chosen member works at the Llanelli office is shown in the table below. Complete the table. Well, we can see that that's half the population, so it's a half. Carnarvon is a quarter, and Newtown and Ebbw Vale together are a quarter, so we've got to half the quarter. So what we're doing is finding out what a half of a quarter is. A half of a quarter, 1 times 1, 2 times 4 is 8. So each of those is an eighth. What is the probability that a member chosen as chairperson works at either the Llanelli or the Ebbw Vale office? Now, just like I said in part A, that if we're using in English the word and, in probability that means multiply. If we're using in English the word or, in probability that means add. So we take the probability of Llanelli and we add it to the probability of Ebbw Vale. Now, in order to add those fractions, we can't do that unless the bottom numbers are the same. So I can multiply this one by 4 over 4 and get it as 4 eighths. Yes, 4 eighths is the same, it's equivalent fraction to a half. So I'm adding 4 eighths and 1 eighth together, which gives me 5 eighths. So again, a bit more practice fractions there. Question 14 is our standard form question. Calculate the value of 2 times 10 to the negative 4 multiplied by 7.8 times 10 to the 9. So you will have been taught that when you're multiplying or dividing standard form numbers without a calculator, you deal with the number parts and the power 10 parts separately. So we can write this as 2 lots of 7.8 times 10 to the minus 4 times 10 to the 9. 2 lots of 7.8 is 15.6. And again, when you were taught this and taught indices, you would have learnt that if the bases are the same, so the 10 bits are the same, when you multiply, you add the powers together, which would give you 10 to the power of 5. Now you've got to give your answer in standard form, and this isn't in standard form because it's not a number between 1 and 10. So to make that a number between 1 and 10, it has to be 1.56. And in order to do that, it's going to shift 1 power further along. So that's going to be the same as 1.56 times 10 to the 6. Part B, again, we want this in standard form. So the first thing to do is to write the bottom in standard form. And that's going to be times 10 to the power of 3. Then we do the 3.9 divided by 3, which is 1.3. And when the base is the same, when it's a division, you add them when you multiply, you subtract them when you divide. So that would be 1.3 times 10 to the power of 5. Question 15, factorize. So we're looking to put this into a bracket. It's the opposite technique to clearing out brackets. So we're looking for numbers that divide, or letters that divide into both that and that. And I can see that 3 is going to go into that. And also I can see that x squared is x times x. So there's an x there as well. So I can take out 3x. So if I take 3x out, 3 goes into 12 4 times, and x divides into x squared x times. Check that, 3 times 4 is 12, x times x is x squared. And then for the second bracket, if I'm dividing, sorry, the second term, if I'm dividing that by 3x, it leaves me a y. And again, I can check 3x times y is 3xy. Another way of looking at that, which when I teach it I tend to do, is to say, right, well, once I've spotted that 3 goes into that, I can write that as 3 times 4 times x, and I can write the second term as 3 times x times y. So when I take out the 3x, I'm left with 4x and y. So that could be an intermediate stage for you if you find that helpful. Question 16, circle theorems. Calculate the size of angle x in the diagram below. So what you're looking for here, or to recognize, is you have a quadrilateral inside a circle. So it's called a cyclic quadrilateral. That has an angle property that the opposite angles add up to 180. So if that is 71, this angle here is going to be 180, take away 71, which is 109. Then I'm in a triangle where I know two sides, sorry, two angles. So 109 plus 26 is 135. So angle x is going to be 180 less 135, which is 45. So x equals 45 degrees. Now, if you haven't done any revision work or if you haven't been taught circle theorems, that won't make any sense to you whatsoever. But we're at the grade B. This is part of the overlap with the higher tier now. Okay, last couple of questions. Question 17. The line AB is drawn below. The point P lies above the line AB, so it's up here somewhere. It's nearer to point A than point B. So that's your perpendicular bisector. Angle BAP is less than or equal to 60, so I need to construct a 60-degree angle there. And AP is greater than or equal to 6 centimeters. So we're going to draw those. Using a ruler and a pair of compasses, construct suitable lines and arcs to represent these conditions. So you wouldn't get any credit here if you were measuring with one of these. You have to construct. So let's deal with each at a time. The first one then, nearer to point A than point B. Perpendicular bisector. You need to open your compass so there's more than half. Draw a curve from A. Curve from B and draw that line. So that is the dividing line between A and B, and it's nearer to A than B, so it's on this side. Angle BAP BAP, so this is where I need to construct a 60-degree angle from A. So I've squeezed in my compass just so that it's more manageable. So to draw a 60-degree angle, you put your compass point on A and you draw an arc of a circle. Then you move your compass point to where the circle crosses the line. And cross the curve again. And this is 60 degrees. So BAP is less than or equal to 60, so it's a smaller angle than that one. And AP is greater than or equal to 6 centimeters. So I now want to find out where that is. So on my compass now, I'm going to open my compass to 6 centimeters. And AP is inside that curve. So let's see if we can work out where this is. So it's nearer to A than to B, so it's this side of that line. It's less than or equal to 60 degrees, so it's inside here, and it's greater than 6 centimeters, so it's beyond that curve. So in which case what we are looking for is this side, under there and over there. So if you're in that green region, you're closer to A than to B. If P is in there, it's going to be an angle which is less than or equal to 60 degrees, and it's further out than 6 centimeters. So that's what you need to draw. And question 18. In the triangle ABC shown below, BAC is 40 degrees and ACB is 80 degrees. X is a point on the side AC such that BX is equal to BC. So that side is equal to that side. Now if that's the case, that triangle is an isosceles triangle. So triangle BCX is isosceles, and in an isosceles triangle the angles at the bottom of the two equal sides are equal. So that means that this is also 80 degrees. So BCX is isosceles, therefore angle BXC equals angle BCX, which equals 80 degrees. Now AXC is a straight line, therefore angle AXB will be 180 less 80. So I know that this is 100 degrees. So in this triangle now, I know two of the sides. So I can work out what angle ABC is. ABX, sorry. So ABX is going to be 180 less 100 less 40, which is 40. Now, if those two are equal, that means it's another isosceles triangle where AX equals XB. So triangle AXB is isosceles, So therefore AX must equal BX. Now that is the proper way of laying that out and explaining it. I would imagine intermediate tier students would not give as complete an answer as that. I haven't seen the mark scheme, so I don't know how those marks would be awarded, but it does instruct you to give you reasons. And that's it. That's the complete paper.